Hello, these are the notes for Mr. Kenzie's integrated algebra class for the quadratic formula and imaginary numbers. You could have picked these up outside of my room. You also could have just downloaded from Google Classroom. Our homework assignments are going to be just to finish the notes, whatever questions we do not finish together. So our first day will be Tuesday, 3/24. You will be working on these two warm-up questions on your own. All you're doing, you're solving this one, so from last unit, and then factoring. So you will not be solving this one. Today what we're going to talk about is the quadratic formula. The quadratic formula is right here. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. You use the quadratic formula to solve any quadratic. So if you are not a fan of solving by grouping, this would be a good method. Just make sure you're careful. Okay, you can also use it to solve non-factorable quadratics. So we're going to start off with number 1. The first thing that we need to do is we need to put this into standard form. So putting this into standard form, I'm going to subtract 7x. So I will have x squared minus 7x minus 3 is equal to 0. Once again, standard form is decreasing exponent value. The next thing that I want to do is I want to state what my a, b, and c values are. A is the number in front of the x squared. Well, number in front looks like there's nothing there, is a 1. The b is the linear coefficient, a number that is attached to x, so that would be negative 7. And our c is the constant, the number that is by itself. So from here, we're going to plug this into our quadratic formula. What I like to do, I like to write the formula, and everywhere there's a letter, I like to put a set of parentheses. This will help with sign accuracy. And then I'm going to go back and plug these in. So I know b is negative 7. I know that a is 1. So wherever I see an a, I'll put a 1. And I know that c is negative 3. Now I'm going to simplify the outside first. So x is equal to 7 plus or minus 2 times 1 is 2. And this number under the radical, known as our radicand. I'm going to use my calculator to do that, but I'm not going to use the actual radical because you could get an irrational answer. What I'm going to do is I'm going to take and plug this in my calculator exactly as I see it without the radical. So I have negative 7 squared minus 4 times 1 times negative 3. All right, that right there is the same thing that is underneath my radical without the radical. I push enter and I get 61. I'm going to put that 61 here. Now, with this, I have to think of factors of 61 that are perfect squares. There are none. All right, so I can leave my answer like this. I also can break this into 2 parts. This 2 belongs to both the radical 61 and the 7. So I could write it as x is equal to 7 over 2 plus minus radical 61 over 2. Another way that I could write this would be break it into 2 separate roots or solutions. So I would have x is equal to 7 halves plus radical 61 over 2. And I have x is equal to 7 halves minus radical 61 over 2. Those are 3 ways you can represent the exact answer. Now, you might not understand what exactly that means with the radical. So I'm going to show you what this actually means. Remember, these are roots. So where it crosses the x-axis, the solutions. So if I would go to my calculator and plug these in. Now remember, you can use the fraction application on the calculator. You can also just plug them in with parentheses. So if I have 7 divided by 2 plus radical 61. Now make sure you arrow outside the radical. Divided by 2. I know that that would be approximately one of my roots. So on my paper, this parabola would cross somewhere between 7 and 8. So somewhere here. That would be approximately 7.405, comma 0. The other one, so if I just take the same thing, and if I don't want to retype because it's the same except for the subtraction sign, if I just do second entry and change addition to subtraction, I will get this. So the other root would cross somewhere on the left side in between 0 and 1. So that root would be negative 0.405, comma 0. Because remember, the roots where they cross the x-axis will always have a y value of 0. So that's approximately a visual of what that could look like. You could also plug it in your calculator. Okay, I'm going to turn over to the next page. The next one we're going to look at is number 3. So number 3, this one is factorable, and I'll know that because my roots will be rational. They'll terminate or repeat. This is already in standard form, so the next thing I'm going to do is I'm going to state my A, B, and C values. So A is equal to 3, B is equal to 7, and C is equal to 2. Now, you may want to write your quadratic formula at the top, just so you have to keep flipping back. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm going to plug this in. So I have x is equal to, wherever there's a variable, I'm just going to put a set of parentheses. I want to replace my A and my C. With parentheses. All over 2a. So now I'm going to plug in. So my B value, which is 7, will go here and here. My A value, which is 3, goes here and here. And my C value, which is 2. So I'm going to do the same thing that I just did before. I have x is equal to, I'm going to simplify the outside. So negative 7 plus or minus, I'm just going to put the radical here. 2 times 3 is 6. This under part here, known as the discriminant, I'm going to use my calculator, plug it exactly as I see it without the radical. So I have seven squared minus 4 times 3 times 2. So I'll get 25. So that's the discriminant. That goes underneath the radical. Now I know 25 is a perfect square. So I'm going to cross that out. And that will come outside as a 5. So x is equal to negative 7 plus or minus 5 over 6. Now, if you notice, there are no radicals in this, meaning we have to simplify more. The first one I have is x is equal to negative 7 plus 5 over 6 and I have x is equal to negative 7 minus 5 over 6. There's the difference of the plus and the minus. So here I have negative 7 plus 5. X is equal to negative 2 over 6, which simplifies to negative 1/3. This one, I have x is equal to negative 12 over 6, which simplifies to negative 2. So this parabola would cross at x is equal to negative 2 and x is equal to negative 1/3. These roots terminate and this one repeats. Therefore, those would be rational roots. We're going to do one more together. That's number 5. So we're going to simplify this radical, as you can see in this text box right here. First thing we need to do is we have to put this in standard form. So we have x squared minus 4x minus 2 is equal to 0. I'm going to state my a, b, and c values. A is number, the coefficient of x squared. B is the linear coefficient attached to x. And c is the constant. And then I'm going to rewrite this in the formula. So x is equal to, I'm just going to put parentheses wherever there's a variable. All right, so we plug in now. And I did make one mistake here. This c should be positive. All over 2a. So I'm going to simplify the outside. So x is equal to 4 plus or minus 2 times 1, which is 2. I'm going to get the radicand simplified, also known as the discriminant. I'm going to plug in, so negative 4 squared minus 4 times 1 times positive 2. Make sure it's a positive 2. I get 8. Now, 8 is not a perfect square. However, it has a perfect square factor of 4. So I'm going to rewrite this. X is equal to 4 plus or minus 4 times 2 all over 2. The 4, we cross that out, it comes outside as a 2. So x is equal to 4 plus or minus 2, because that's the square root of 4, radical 2 over 2. Now our simplification is going to be a little bit different here. I'm going to take this, and I'm going to break it into 2 parts. I'm going to have x is equal to 4 over 2, as we did in our first example, plus or minus 2 radical 2 over 2. 4 over 2 simplifies to just 2. These 2 simplify to 1s. Can't simplify this 2 underneath because there's a radical. So I can leave my answer like this, or I could do this as x is equal to 2 plus radical 2, x equal to 2 minus radical 2. So your homework for tonight will be to do numbers 2, 4, and 6 on this page, and the 2 warm-up questions on the previous page. Thank you.